so first of all, thank you for coming. I didn't expect so many people in this room today. Hopefully, I will not bore you. Hopefully, let's see. So today, I'm going to talk about next generation of front-end architectures, aka reactive programming. My name is Luca. I'm living in London. I'm solution architect for The Zone. I'm a Google developer expert on web technologies, and I'm the community manager of the London JavaScript user group. Today, we're going to talk a little bit about the current status of architecture in the front-end panorama. And then we are going to introduce reactive programming. And last but not least, a fully reactive architecture called MVI. So let's start with a little bit of history, because we are living in Italy, so usually history is something part of our life, right? So let's talk with probably the best slide that I ever created in my entire life. That is this one, is an architecture timeline. Here, basically, we start in the 80s with MVC. I think more or less all of you, I hope, at least once has worked with MVC. So I will not spend more time on here because we have a lot to talk. So let's move ahead and talk about MVP. So we have in the 80s MVC, and now in the 90s, there was this new architecture called MVP. MVP stands for Model View Presenter. There is a fundamental change between MVC and MVP because the model and the view in the MVP architecture, they don't know each other. They are completely agnostic, and there is the presenter that is retrieving the data that the view needs to display, and it's basically stays in the middle between the view and the model, and he has a great benefit because the presenter has a relation one-to-one with the view, and that means potentially what the presenter is doing is driving and controlling the view. It's not like a controller, it's similar, but it's not like that. The view in this case is a passive view. Passive view is a well-known pattern. If you check the Martin Fowler blog, you will see it. And the interesting part of using MVP, in particular when you work on cross-platform application, is the fact that the view can be switched during transpilation time or compile time, depends on the language that you're using. And usually MVP is the perfect architecture when you want to work on a cross-platform application. So when you want to switch, for instance, you want to have the same behaviors on mobile and I don't know, on web and on, I don't know, smart TV, but you want to change the views and how these data are represented. Slightly later, Microsoft introduced in 2005 MVVM, Model View View Model. I think most of you are familiar if you have worked with Angular. The difference here between MVP, can you hear me again? Okay, cool. MVP and MVVM is the fact that MVVM has the view model that is slightly different from the presenter. In this case, the view model is not associated to the view one-to-one, but in this case, the view model can update multiple views. It's retrieving again the data from the model and is updating the view that is not anymore a dump view or a passive view. Is updating the view through let's say watchers and bindable variables. It's a different paradigm, but slowly, as you can see, we are evolving, right? So in 2009, the same creator of MVC created the MVC2 that is called DCI. How many of you heard about DCI? None. Okay, cool. So DCI stands for Data Context Interaction. The interesting part of DCI is a lean architecture and is embracing for the first time a concept that is less related to the machine, but more related to the business. With DCI, what we are doing is defining a context where the data and the interactions, so the behaviors, are dealing together. And if you're not familiar with this paradigm, I really suggest to keep an eye on it. It's not super new, but definitely there are a lot of great concepts behind that. And for sure, there is a JavaScript library that is using and leveraging DCI. And then in 2013, Facebook released Flux. Flux is not just a framework, it's the design pattern. And the interesting part of Flux is that it's talking more about flow, so data flow. In this case, unidirectional flow. And it's a super strong concept because when Facebook came out with Flux, leveraging the concept of unidirectional flow, finally we had someone that is saying, okay, with Flux, we have the opportunity to have any new developer joining our company and immediately starts to work on it and knowing what they are doing, because they don't have to understand anymore which is the flow of the application, because the flow is unidirectional. It's always in the same way. So if there is a problem or retrieving the data, you know that are on the action. If you know that there are a problem on displaying the data, you know that are on the view. So here we are completely changing the way how the architecture were built in the 80s and moving more on flows, asynchronicity, instead of dealing with, let's say, a more machine concept. In 2015, a company called Futurist starts to blog about MVI. MVI stands for Model View Intent, and we will see later on what it's capable of. So the real question is what we are trying to achieve with event-driven architecture. This is the real question, because at the end of the day, the communication can be done in several ways. I think if someone of you work at least once in Node, is familiar with the event emitter. Or you are familiar with listener and events, stuff like that. As you know, there are several ways to communicate between objects. And today I would like to introduce a new one. You can use, obviously, events. You can use signals. You can use a pub subsystem. You can use action dispatcher, like in Flux. So there are several of them. And this is very important because each of these techniques will allow you to achieve different things. And today, I want to introduce a new way to communicate with the object. I would like to talk about reactive programming. Quite often, when you read about that blog post on the web, often reactive programming is associated with React.js. It definitely is a big part of reactive programming world, but the real problem is only few people are talking about how to put it in production. Yes, you can use with Angular, but Angular is not a reactive architecture, right? So let's see what is first reactive programming. As you know, there are different programming paradigms. There is imperative, where we are describing step by step what we are doing inside our software. There is functional, that is obviously leveraging the concept of functions. In this case, introducing the concept of pure functions. So where you know exactly what is the result of a function if the argument is always the same. Obviously, functional is not just that, it's way more than this. But for what we are carrying at the moment, it's more important understanding this. And last but not least, we have reactive. In reactive, we are talking about flows, data flows in particular, and how to handle the asynchronicity that basically we are dealing every day in our front-end applications. But what is reactive in practice? So sometimes at the beginning, when you start the journey on reactive programming, the first issue is dealing with the ecosystem, because there are a lot of new terms, and you have to understand properly what they are meaning, because otherwise you don't understand how to implement them. So let's start with the basic. So usually when you work with a dependency injection, you injected an object inside another one. Usually the object A is triggering or calling, invoking some methods inside the object B. And this is how we are used to work. What is changing in reactive programming is that we are not doing that anymore. What is changing is, yes, there are, let's say, a sort of link between these two objects, but it's not strong and tight like the previous one. The main difference now is that the object A is, let's say, pushing some information inside a data flow, and someone else, in this case object B, is reacting to these changes. They don't know each other at all. They don't know that they exist. They are just, one object knows that he has to push some data inside another object, and someone else is listening for that. And it's a complete separation between these two objects. Okay, well, because I don't like just to show slides, but I'd like to show also some real example. Let's see a simple reactive example. So I worked for a year and a half in a gambling company in London. And yeah, one thing that I dealt with is the bingo. So I think that bingo is the perfect example that I can show you in order to understand how it works. Let me start this. Okay. Okay, so this one is very simple. So we have bingo for Italians are tombola. Okay, so we have, let me move here. We have 2 tickets. So our user has 2 tickets composed by 15 numbers. Okay, nothing else, unique numbers. And then there is an engine that is basically calling different numbers. This is how bingo works, quite simple. Usually, obviously, the engine is on the server, but for the purpose of this example, I decided to do on the client. So as you can see, we are calling some numbers. We are validating if these numbers are inside the ticket, and when they are present, we are just changing the line here. Something very simple. We don't care currently about the view and all the rest, but let's focus on how the interaction works. So let's start from the beginning, apps. So the apps create... Can you zoom in a little bit to code? Yep. Better? Okay, cool. So the apps is creating mainly free objects, the engine and 2 tickets. And how they are interacting together is just through a stream. And we will see later on what is a stream, but you can see in practice right now. Let's move here. So let's talk about the engine. So the engine is, if we read these 5 lines of code, we have an array that is where we are inserting some value that are unique value. And we know that there are a certain number of this value, in this case 40, because my game is composed by 40 ball calls. And then in order to pass this information every now and then, so every 3 seconds in this case, because we have interval, we are using what is called in reactive programming an observable. So think about a little bit about the observer pattern. The observer pattern is exactly that. So you have a subject that I can subscribe to this subject, and every time that there is a notification, I'm just listening to it. So every time that is notified, there is the subject that is calling through an interface the notification. Usually the method is called update, and you react to this thing. In fact, the observables, at the end of the day, are just a mix of 2 patterns. It's just a mix of observer pattern and iterator pattern. Iterator we should be quite familiar with, so I don't mention it. So what is happening here is basically I'm just describing what I want to do. So every now and then, so I create an interval method. You have to dispatch a value. Obviously, with interval, we are incrementing the value from 0 to, in this case, 40. And every time that there is a value, so a call, this value is passed inside the map function. So it's this guy here. And then we can use the map function to retrieve a specific value inside my array. So in this case, as you can understand, we start from 0, so we are iterating the array. And when it's finished, all these values, where they are going? They are inside this guy here called stream. Inside the stream, I have all the values that are synchronized every now and then. So how the ticket is reacting to this? So the ticket, the only thing that here is receiving the observable, and is creating is subscribing to it. And in this case, we have always 3 methods. We have when we receive the data, when there is an error, and when it's complete. So basically, I can handle inside this stream all the action that can happen inside this. Let's think about a channel if you want. And when the data is arriving, I'm just checking if it's inside my ticket. But between the ticket and the engine, there is no correlation. The only thing that they are doing is just streaming some data inside it. Quite simple. Then another cool thing that we can do with reactive programming is solving a problem that in a bingo system is quite painful sometimes. So what we can do, for instance, is let's assume that you start a game. I buy 1 ticket. And during the game, that usually is 3 minutes, 4 minutes, depends from the game, you can also, the user can also buy another ticket. But in that case, if the user bought another ticket, we have to validate all the previous numbers that were called. So how can we solve that in reactive programming? So usually in imperative programming, we do something slightly different. So we create a buffer. and we use this buffer, but in order to handle the logic, it's quite painful sometimes. So let's assume that we are in reactive programming. What's happening here? Okay, so here what I'm creating is, again, same thing, but after 5 seconds, I create a new ticket. As you can see, the code is more or less the same. So let's move here. So I have the first ticket, my first ticket, and after a while, boom, I have 81. Let me increase also this one. I have 81 that it was called by the engine, 98 and so on. And when I bought the second ticket, I immediately check the first few numbers before going back to check in parallel ticket 1 and ticket 2. So how is possible with reactive programming? In reactive programming, you have, let's say, the possibility to create the buffer in React.js, in this case, automatically. So you don't need to create weird logic, stuff like that. My code is changing compared to the previous one. Let me take this. It's changing only for one method. Here we are. That is share play. So I have exactly the same logic. I have exactly the same thing. But in this case, I'm creating a buffer. I can also define how big is my buffer. So React.js in this case is very friendly and will allow us to do a lot of things. Another thing that I forget to mention that is very interesting on this case, as you can see here, I don't keep the state anywhere. I just have a flow of the data that are living inside my for function. At the end of this, I'm sharing the final value inside the stream. If I want to debug, I have also the methodology to debug it without create any external variable. So it's pretty handy, honestly. Okay, but move on, because we have quite a few other things to talk about. So, okay, so we talk about streams. A stream, I like this definition, is a sequence of ongoing events ordered in time. So basically, here we are dealing with the main problem when you are working on a front-end application, dealing with asynchronicity, because 99% of the time you have to call the server and retrieve this data and create the view in order to react from this value. So remember one thing that is very interesting, everything can be a stream. And this diagram here is what in reactive programming is called marble diagrams. And it's showing a specific stream or observables, because observables is a special type of stream, where we are passing at a certain point the value 1, the value 2, then nothing, and then after a while the value 3, and so on. And then there is the completion of my stream. So after that line, nothing can happen, the stream is dead. Potentially, if you see an X, it will mean that there is an error. But as you can understand here, you can also represent this. And it's very handful understanding how they work, because also when you test this thing, using marble diagrams is a very easy way to do. React.js 5, for instance, will allow you to test the streams just in HashiCode. So you just recreate this, and you say, okay, at a certain point, I will have, I don't know, hash, this time, then a value, then hash, then a value, and then you can do the merge of the stream. You can manipulate the stream as much as you want. So it's pretty handy. So as I said, it's based on the observer pattern. I left this as reference. And this is in a nutshell let's say, what you can really do with reactive programming. So you're handling the asynchronicity. And it's something that we dealt with it for several years in different languages on front end. If you remember the old good times of Flash, for instance, that there were, let's say, several ways to do that. But usually, when you have an observer pattern, you solve 99% of the problem, in particular on Flex projects. But let's talk about how to create a full architecture totally reactive. And that's why we are here today. So model view intent is a new architecture that was created quite recently, honestly, 2015, we said. And the interesting part is that currently, I think it has a lot of power and potentials, but definitely it's not something that is totally finished. I don't think it's the final architecture that we will see in reactive programming. Currently, there are several others that are growing up quite fast. But let's see the difference. So let's start with the basics. So let's talk about model view presenter first, just to do a comparison. So we have the view. that we are familiar, everyone, with this. As I said, is a bidirectional communication. So the view is exposing some data to the presenter, and they are communicating together. And the presenter is retrieving the data from the model and is handling the view. So there is, let's say, a two-way communication. Model view intent is totally different. So model view intent is leveraging some concepts that are evolved in the last few years. We said at the beginning with MVC, MVP that there is more a concept of machine. And in 2010, almost, there was the concept more close to the business. OK, MVI, in my opinion, is taking the best of these two concepts, and they are trying to put together. So in this case, we have, OK, let's go. As you can, first thing that I want to highlight is where the arrow is going. The arrows in this case are unidirectional. So the direction of the arrows are always the same. So the view usually has, the view is containing not really the real view, so the DOM elements, but is taking, is using creating the virtual DOM. So usually MVI is used with libraries like React, SnapDOM, stuff like that. So the library that are using mainly virtual DOM. The interesting part is always more than a module is always a function. So we are talking here about an input that is data events from the model, and there is an output that is a virtual DOM that will be used by the renderer in order, so in this case, SnapDOM or React, in order to visualize something. The intent that is something new is not something particular complex. It's just receiving the user input, so basically it's retrieving from the DOM the different value that he needs, and is returning to the model something that he's familiar with, so the data, the interaction that the user did inside the view. And then we have the model that we are familiar, and we are keeping the state here. So inside here, basically, we are just taking all the interaction that the user does and returning the data that will be used later on to the view, from the view in order to render something. There are really few rules for MVI. There is the model shouldn't control any other module because they communicate only through observables, like we saw before in the bingo example. The only shared part are observable, as I said, and the intent is not something particular complex. It's just a way to retrieve the data and the interaction from the user and translate them in something that is familiar for the computer. So before we move, let's go ahead, and then I will show you the next example. One library that is perfectly working in a fully reactive and functional way is Cycle.js. Are you familiar with Cycle? Yeah, one, two, a little bit. OK. Cycle.js was created quite fairly recently. It's leveraging this concept. So again, as you can see, we are not talking anymore about data and computer stuff like that, but we are talking about also the human aspect. So we have a human that is interacting with a computer, where he has an input, and there is always this circle. So the computer elaborates the data and prepares an output that is fetched from the human through eyes and so on. And this circle is continuing. So they are Andres Stals based, that is the creator of Cycle.js, based this idea, used this idea in order to create Cycle. Cycle is not something particular complex. It's just a set of functions that you can use in order to create your application, and they are all pure functions. So they are not creating side effect. In order, every time that you know for sure that every time that you deal with the function in Cycle is always a pure function. It receives some source and returns some things. So at the end of the day, let's say it's very easy to debug, it's very easy to understand, and it's nothing particular view. So let's see it in action. OK, so let's move away from here. Let's go. Whoops. X. OK, this is a simple demo, if it's working. Oh, here we are. OK, so these are live data from the tube in London. Okay, so what I'm doing is just ingesting some data from the Open Data City of London, and I can see I'm grouping them in order to see the final destination of the trains, and I'm showing inside my view. Obviously, these are updating every now and then, as you have seen right now, and it's updating because obviously the training are moving, and I can check each single line. So I don't know, I want to see the Beckerloo line. Here we are, I have the data. Something simple, right? nothing particularly difficult to create in any way that you are creating that. But let's try to create in the right way. So Cycle, so in this case, for instance, one thing that I want to highlight is we are totally asynchronous. So the view depends totally from the server. So in order to display stuff, I need to receive the data. I don't know when I'm receiving them, and I want to display the data only when they are changing. That is the classic thing that is happening on any application. Usually, for instance, Cycle, let me increase the font before they ask me again. Okay, cool. In this case, Cycle is very simple library. It's composed by one method, one public method, run. That's it. Obviously, you have more stuff currently in Cycle. You have the possibility to call HTTP request, and you have the possibility to render the stuff through Snapdom and stuff like that. But Cycle per se is just 100 lines of code, nothing more. And what you're passing here is just passing your application and the drivers. The drivers are where in Cycle we are creating the side effects. So in this case, rendering the DOM and retrieving the data from the server. So here I created, in the repository of this project, I created 3 branches, and you can see the different ways. So you can work in the normal way that you see the first example in Cycle, then in MVI with the old Cycle, and then in MVI with the new Cycle. So when you go to my GitHub repository, you can find it. The interesting part here, again, is that we have all functions. We have function view, function model, and function intent. And what they are doing is always receiving some value and returning a stream or an array of streams. What we call is observable or observables of observable. And in this case, the communication between these 3 is only for that. So let's start, for instance, when we receive some data. Let's start from the networking. So here is the side effect that we are doing to retrieve the data from the internet. So what I'm doing is calling, an HTTP request, and this is interesting. So this is a classic example that I love about reactive programming. So, for instance, we have the case that I want to refresh let's say, my view every now and then, and it's defined by this interval time. And I have also to call the data. So I create a stream for that, because everything can be a stream in JavaScript. And I call this data, I receive the data, and in order to have both, so every now and then I'm retrieving this information, I combine the 2 streams. So I can combine the streams, I can also manipulate the data inside the stream. And the cool part is that it's living there, so you don't have to do crazy things inside the model or inside the controller, so even worse inside the view, where you want to manipulate data for a specific thing because your model is not taking care about that. You can do inside the stream, and in this case, it's super clean, because at the end of the day, what you are doing is manipulating or combining, merging, and doing whatever you want with this stream, and the data are living only inside there, so you are not creating something that is spread across your application, so it's not keeping the state at all. So I'm receiving this thing, so this bunch of lines of code is just for retrieving the data every few seconds. And when I receive the data, what I'm doing is just selecting which is the code, because I can have multiple codes. Potentially, I can create, if I have sequential codes, I can create all of them and queue all of them, and automatically everything is handled by the library. I retrieve the JSON that is provided, and I parse it. Nothing else. Inside, this information are obviously, when I retrieve this data, are passed inside response inside the model. These are the information that the model needs and needs to use in order to update the view. But at the same time, the model needs to receive the action, so the interaction that the user does inside the application. As you remember here, I have my amazing drop-down, not customized, by the way, where I need to pass this information because I need to display the right content to the user. So as you can see, always I have my different part of the application, so model view intent, and I always have a returning object. We use what is called the finish notation, that is this the dollar at the end of the variable, just to define that that specific variable is, or constant in this case, is a string. So that is an observable. And immediately I can understand when I read the code that I'm not dealing with a primitive number or a primitive object or an object, an array or whatever, but it's an observable. So I treat it in the way how it deserves. What I'm doing then, so let's start from the intent. So when I change the dropdown, obviously I listen for, or I translate the listener of events change to a stream, and every time that is changing, I returning an object inside the stream that is based on the label and the value of it. These information are passed to the model that obviously are used in order to retrieve the different information that are stored here. And based on the data that I receive from the train and the line, I combine them in order to create a state that will be used for the view. And the view is doing that. Look at that, very simple, very functional as well. So I'm creating the view with SnapDOM. You can use also JSX if you're more familiar, but let's say SnapDOM is, let's say, the library that you have out of the box with Cycle. And what is happening here is just I'm creating the UI, and after normalizing the data, because obviously, as you can understand, the data provided by Open Data are quite complex, and I didn't need all that information. I just prepared that, sent to SnapDOM, and took the result and start to create my information. And when I finish, I just call another function, this render strange data. I'm preparing everything. This is the part of the virtual DOM. So I'm preparing the virtual DOM. I'm not rendering anything at this moment. And when I want to render stuff, I just pass the v3 inside my driver, because this one is what is returning. So my application is returning always the driver. And if you remember here, we have here the method that is passing the app and the drivers. Inside that run method, there are some checks to understand if app and drivers are some objects or are strings or whatever. Obviously, if it's a string or a primitive object, it's going to blow up. But if you have app and drivers together, they are creating the glue in order to create the cycle of this application. It's at the beginning a little bit strange how it works, but after a while you became familiar and you can create a nice thing. There is one thing that I love to mention about this. That is, okay, before we move here, that is Cycle, as you have understand. Let me go back to the architecture. Here, okay. As you can understand, is creating. You can create this application through MVI. MVI is what is called a fractal architecture, because potentially you can take this simple example that I've shown you a few minutes ago and be part of a more complex application. And in order to do that, you just create, let's say, a container that is another MVI. And because MVI is unidirectional, and you can create smaller components, or you can create a large application composed by several other components based on MVI without have any clash inside your code. And this is something that is matter, in particular when you have large and complex applications. Let me move back here. There are, if you want to start with Cycle, I just share a few of links that could be useful. So Cycle.js, also Cycle is just a GitHub repository where you can find a lot of talks and information around that. Cycle.js Fundamentals, that is a free course, video course on Egghead. And one of my favorite talks is a unidirectional data flow is made by the creator of Cycle, Andres Staz. The real question is, okay, we have this new shiny thing. Do we use everywhere? And that's the problem. As I said, I'm running a JavaScript community in London, and often I see developers that are starting to deal and play with the latest cool thing. It's something that personally, as architect, I don't understand, because obviously I like to use the right tool for the right job. This is something that, for me, reactive programming should be used in the same way. Obviously, if you're using, I don't know, if you're creating like a static website that is not, let's say, having a lot of interaction, I struggle to see the benefit of reactive programming. But what about creating a financial dashboard? Here is where reactive programming is shining. And that's the important thing, because you have to understand that here we are dealing with a shift of mindset of your developers. And the other thing is you are dealing with stuff that at the beginning people will struggle. So I spent by myself quite a few months in order to mastering and understanding how to deal with it. And it would be the same for, I believe, for everyone. And if you want to use this thing, for sure there is a lot of benefit. If you have a game that is asynchronous, yes, reactive programming will save your life. You will have way less code to debug. You will have less code to write. But definitely, you have to use it in the right way. You can't use just because it's the new shiny thing. This is the most important thing for me. Last but not least, I'm working for this company. As I said, I'm based in London. So if you're thinking to relocate in London or you're already in London, we are looking for front-end and back-end developers. So if you are interested, please let me know later on. And that's it for me. Thank you very much.